Here's problem 39. In the figure shown, if A is equal to 1 centimeter, B is 3 centimeters, and I is 30 amps, what is the magnitude of the magnetic field at point P? Alright, we have this drawing. It's not necessarily drawn totally to scale because A should be 1/3 of B, but we do have A 1 centimeter here, B here, and we have 4 segments to consider. 1, 2, 3, and 4. And looking at this, if we look at segment 1 for that curvature, if we point our thumb in the direction of the current, then everything to the interior of the curvature will be into the page. So at point P, we're going to have a magnetic field B1 that will be into the page. And at segment 3, using the same right-hand rule, everything to the interior of that curvature will be out of the page. So due to magnetic field 3, at point P we'll have a field coming out of the page towards you. 2 and 4, magnetic field is 0 because we're off the end of those segments. So we can say that B2 is equal to B4 is equal to 0 because we're off the end of those segments. So we don't have to worry about those. So let's calculate B1. That's going to be mu naught I over 4 pi r times angle theta, and that's going to be 4 pi times 10 to the minus 7 from mu naught. Current is 30 amps over 4 pi. The radius of curvature is B, which is 3 centimeters, 0.03 meters. And the angle we're talking about is 90 degrees, or in radians, pi over 2. So we have 4 pi's cancel out. And what does this come out to be? 1.57 times 10 to the minus 4 Tesla. And of course that would be, as we said, into the page. Okay. For magnetic field 2, we have mu naught I over 4 pi, we could say R2 times theta. In this case, R is equal to radius A. So we have 4 pi times 10 to the minus 7 times 30 amps over 4 pi. Radius A is 0.01 meters, and we have the same angle, pi over 2. So the 4 pi's cancel out, and this is equal to 4.71 times 10 to the minus 4 Tesla. And as we said, that would be out of the page towards you. So they're in opposite directions, and the larger one is going to subtract the smaller one. In other words, the larger one is going to prevail. And so our net field is going to be equal to B2, B3 minus B1. So that's going to be equal to 4.71 times 10 to the minus 4 minus 1.57 times 10 to the minus 4. And that is equal to 3.14 times 10 to the minus 4 Tesla. Or we could write this as 0.314 millitesla. And that would be out of the page towards you. So that is the magnetic field at point P, 0.314 millitesla.